In this short video, I want to prove that the matrix P defined as phi times inverse of phi transpose phi multiplied by phi transpose is a projection matrix. That is, it has to satisfy the following two properties. The first one is Vm transpose y equals 0, where Vm is the projection, that is, of vector V, and we have to prove that, and y equals V minus Vm. And the second property is that if a vector V is in the null space of phi, then Vm should also satisfy that equation. That is, Vm should also be in its null space. If this is satisfied, then this should be automatic. This should result in this, that Vm is in the null space of phi. So let us see the first property. That is, Vm transpose y equals, now using the definition, P times V, that is phi multiplied by its inverse, phi transpose multiplied whole transpose multiplied by y, which is V minus Vm. So if we rewrite that, it is V transpose, and the transpose of this product is still the same thing, this phi transpose phi inverse phi transpose, and we again have V minus the product of this matrix with the Vm. So which is again phi transpose phi whole inverse phi transpose, and there is a V transpose here, and then again we have another PV, that is Vm is actually equal to PV, that is again phi multiplied by phi transpose phi whole inverse phi transpose V. You see, these two cancel out, so we are left with the same thing as the first term, which is equal to 0. Hence Vm transpose y equal to 0. If you observe carefully, this is very similar to y phi transpose y equal to 0. That is, Vm is actually Vm is in the span of phi. That is, we can easily verify this property, right? That phi transpose y equal to 0 by just substituting V minus Vm in the value of y. And phi transpose V minus Vm can be easily proven to be 0. So this is one of the properties, that is Vm is in the span of phi. The second property is that if the vector V that the Vm has to satisfy this. The second property is that Vm has to satisfy this condition, that is, that if this is true, then this should be true. So let us start with the left hand side. Equal to 0, that is phi transpose phi transpose phi inverse phi to V equals 0. This implies phi V equal to phi transpose V equal to 0. Hence, thus P projects V onto span of the columns of phi. So thus P is a projection matrix. And similarly, we can also derive that when phi transpose V equal to 0, this implies phi transpose Vm equal to 0, provided Vm is equal to Vm is a projection of V. That is, by simply multiplying with phi transpose phi transpose phi whole inverse phi transpose V equal to 0, that is basically multiplying with identity on both sides, you get, and this part is basically P, that is phi transpose PV equal to 0, and then phi transpose Vm equal to 0. Hence, if V is in the null space of the phi, then its projection is also in null space, and if the projection is in null space, V is also in its null space of phi.